Have you ever wondered how we came to measure temperature? The story begins in the year 1593 with the brilliant mind of Galileo Galilei, an Italian astronomer, physicist, and engineer. It was Galileo who invented the first known thermometer, a simple device that would forever change how we perceive and interact with the world around us. Galileo's thermometer was a marvel in its simplicity. He took a glass tube and filled it with water and air. The tube was then sealed, effectively trapping the air inside. This trapped air was the secret ingredient to Galileo's thermometer. As the temperature around the tube changed, so too did the temperature of the trapped air. This caused the air to expand and contract, which in turn moved the water level inside the tube. This simple concept, that air expands and contracts with temperature changes, was a revolutionary idea. For the first time, we had a way to measure temperature changes in a standardized and repeatable way. Yet, it was more than just a practical tool. Galileo's thermometer was a physical representation of a fundamental scientific principle, a principle that remains at the heart of thermodynamic science even today. But Galileo's contribution went beyond the invention of the thermometer. His work laid the foundation for our understanding of temperature. Before Galileo, temperature was a subjective experience, something felt rather than measured. Galileo's thermometer changed that, turning temperature into an objective quantity that could be studied, measured, and understood. It's fascinating to think that such a simple device could have such a profound impact. But that's the beauty of science. Sometimes it's the simplest ideas that lead to the greatest discoveries. And in the case of the thermometer, it was a simple tube filled with water and air that led to a new understanding of the world around us. So, the humble beginnings of the thermometer can be traced back to Galileo's simple invention in the 16th century. A simple device, yet one that has had a profound impact on science, medicine, and our everyday lives. And it all started with a glass tube, some water, and a bit of air. Fast forward to the 18th century, the thermometer took a revolutionary turn. Enter Daniel Gabriel Fahrenheit, a physicist who would forever change the world of temperature measurement. In the heart of Amsterdam in 1714, Fahrenheit invented the mercury in glass thermometer, an instrument that, despite its age, still finds relevance today. So, how does this thermometer work? Picture this: a bulb filled with mercury attached to a narrow glass tube. The mercury in the tube is much less than what's in the bulb. With changes in temperature, the volume of mercury changes slightly, but this small change is enough to drive the narrow mercury column a relatively long way up the tube. The space above the mercury may be filled with nitrogen gas, or it may be at less than atmospheric pressure, creating a partial vacuum. To calibrate this thermometer, the bulb is brought to thermal equilibrium with a temperature standard such as an ice-water mixture, and then with another standard such as water vapor. The tube is then marked at regular intervals between these fixed points. Now, you might wonder, wouldn't thermometers made of different materials give different readings? In principle, yes, but the substances used are chosen to have reasonably linear expansion characteristics as a function of thermodynamic temperature, resulting in similar results. Now let's talk about the mercury thermometer's physical properties and temperature range. Mercury thermometers can cover a wide temperature range from -37 to 356 degrees Celsius. The upper temperature range can be extended by introducing an inert gas like nitrogen. This increases the pressure on the liquid mercury, raising its boiling point, and when combined with replacing the Pyrex glass with fused quartz, can extend the upper range up to 800 degrees Celsius. Fahrenheit's mercury in glass thermometer marked a significant advancement in temperature measurement. This invention not only revolutionized the way we measure temperature, but also set the foundation for the development of modern thermometers. A testament to Fahrenheit's genius, the mercury in glass thermometer remains an enduring symbol of scientific advancement and innovation. But could we measure temperatures beyond the limits of mercury? This question led to innovative explorations that pushed the boundaries of temperature measurement. The upper limit of mercury thermometers was traditionally around 356 degrees Celsius. To extend this, scientists introduced an inert gas, such as nitrogen, into the thermometer. This increased the pressure on the liquid mercury, subsequently raising its boiling point. The addition of nitrogen alone, however, wasn't enough to significantly expand the upper temperature range. To further enhance the thermometer's capabilities, scientists replaced the traditional Pyrex glass with fused quartz. This combination of nitrogen and fused quartz allowed the thermometer to withstand temperatures as high as 800 degrees Celsius. This was a significant leap from the previous upper limit, broadening the scope of temperature measurement. But what about the lower end of the scale? Mercury solidifies at minus 38.83 degrees Celsius, rendering the thermometer useless below this temperature. If nitrogen is present in the thermometer, it can flow down into the column when the mercury solidifies and get trapped as the temperature rises, rendering the thermometer unusable. To overcome this limitation, a mercury thallium alloy was introduced. This alloy does not solidify until the temperature drops to minus 61.1 degrees Celsius. This allowed for the measurement of much lower meteorological temperatures than previously possible with a standard mercury thermometer. These advancements in thermometer technology opened up new possibilities in temperature measurement. By pushing the boundaries of what was thought possible, scientists were able to create tools capable of accurately measuring a wider range of temperatures. With these advancements, thermometers could now accurately measure a wider range of temperatures. This is a testament to the power of curiosity and the relentless pursuit of knowledge. When we dare to question and challenge the status quo, we can push the boundaries of what is possible and continue to advance our understanding of the world. Today, thermometers have evolved far beyond mercury and glass. Let's dive into the world of modern thermometers and discover how they're pushing the limits of temperature measurement. In our pockets, homes, and offices, digital thermometers have become commonplace. These rely on electronic sensors known as thermistors. When the temperature changes, so does the resistance in the thermistor, and these changes are converted into temperature readings. Digital thermometers offer quick results, making them a popular choice in many fields. In the medical world, for instance, digital ear and forehead thermometers provide a non-invasive way to check body temperature. They're user-friendly and can deliver accurate readings in a matter of seconds, essential when dealing with patients, particularly children. Infrared thermometers, on the other hand, take temperature measurement to a whole new level. They measure temperature from a distance using the principle of infrared radiation. These devices have seen a surge in use recently, especially for mass temperature screenings in public spaces during health crises. Then, there's the world of smart thermometers. These devices connect to our phones or tablets, providing real-time temperature readings and even tracking temperature changes over time. They're used in various fields, from healthcare, where wearable thermometers can monitor body temperature continuously, to cooking, where meat thermometers ensure your roast is cooked to perfection. In meteorology, advanced thermometers help monitor and predict weather patterns. They can measure temperature at various atmospheric levels, providing crucial data for weather forecasting. And let's not forget about laboratory thermometers, which are fundamental in scientific research. They can measure extremely high and low temperatures with precision, contributing to advancements in fields like physics, chemistry, and space science. From Galileo's simple tube to today's smart devices, the thermometer has come a long way. They've become more than just tools for measuring temperature. They're now integral parts of our daily lives, helping us stay healthy, cook better food, understand our climate, and push the boundaries of scientific knowledge. let's revisit what we've learned about the history of thermometers. We've journeyed together from the birth of the thermometer, a historic event that took place in Amsterdam in the year 1714. The genius behind this invention was physicist Daniel Gabriel Fahrenheit, who created a mercury in glass thermometer, a clever device that consisted of a bulb filled with mercury attached to a narrow glass tube. Remember how we discussed that the volume of mercury in the tube is significantly less than the volume in the bulb, and how this small change in volume drives the narrow mercury column up the tube. And let's not forget about the importance of calibration. Getting the thermometer to reach thermal equilibrium with a temperature standard like an ice and water mixture, and then another standard such as water vapor, is crucial for accurate readings. We've also delved into the world of modern thermometers and their uses. Today, thermometers made of different materials, like colored alcohol thermometers, are designed to have reasonably linear expansion characteristics as a function of thermodynamic temperature, and so they give similar results. We also explored the physical properties of mercury thermometers, which cover a wide temperature range from -37 to 356 degrees Celsius. And we've learned that the instrument's upper temperature range can be extended by introducing an inert gas like nitrogen, which increases the pressure on the liquid mercury and therefore increases its boiling point. But mercury isn't perfect. It can't be used below the temperature at which it solidifies, which is -38.83 degrees Celsius. To measure lower meteorological temperatures, a thermometer containing a mercury thallium alloy, which doesn't solidify until the temperature drops to -61.1 degrees Celsius, may be used. So, the next time you check the temperature, remember the fascinating journey of the thermometer. From its humble beginnings to its current essential role in everyday life, the thermometer's history is truly a testament to human innovation and ingenuity. Thank you for watching.